problem, sir. Not this one, sir. After this one.
This one, right?
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Let's go. Profit that is that only, not profit. That is equal to is equal to 3, 4, 1, 7. Right. Constraint so x1, x2, x3, 4 constraints are 8, 3, 4, 1, 2, 6, 1, 5, 1, 4, 5, 2, only 3 constraints, right?
Yes, sir. 3 constraints.
3 constraints. Allocated and closed. So allocated is 738, right?
Yes, sir.
8. Okay. So maximum is equal to this into this plus this into this into into this into this this. So V2 we have to fix.
Yes, sir.
F2 we have to fix. G2 we have to fix. H2 we have to fix. Press enter and then I'll drag it down. Now data place solver maximum cell is this. Then max by changing values this. Then subject to constraints add condition this less than equal to constraint this add condition this less than equal to this add condition equal to this constraint is this click OK. Okay, Simplex LP. Okay. So you got 4.368. The value what?
Yes, sir. Yes, sir. I got this. This one. 4.368. All right, sir. It's matching, sir.
Got it?
Yes, sir. Yes, sir.
So today we are doing Simplex method minimization. Simplex method minimization. So what is the process involved in minimization?
So we have to minimize cost.
See, the simplex method for minimization. We call it as what? We call this as, this method we call it as dual maximization. You will use dual maximization for solving the minimization problem. So, dual maximization is transpose of augmented matrix, the augmented matrix or the initial matrix of minimization problem. So we will first frame the minimization problem into a matrix form and then we transpose that matrix. When I say transpose of, so what is transpose basically?
Is it inverse, sir?
What is transpose? Basically, what does the step transpose do?
The transpose means the rows are converted into columns and
Yes,
columns
rows
converted
changed
into
to
rows.
columns and columns are changed to rows. Now, this has to be done only on the last row and the right hand side. Transpose of last row and right hand side values. Only these values will be transposed. Rest of the matrix will remain same. No, we have to transpose completely. Oh, sorry. Transpose the matrix by interchanging rows and columns of augmented matrix. Of augmented matrix or the initial matrix. That we call it as okay. So we have to convert the minimization problem into maximization problem using the transpose method. This process we will call as dual of the minimization. So the duality principle, von Neumann duality principle is what generally it is used. So the von Neumann principle or principle of duality is used. Okay. So simplex method for minimization is nothing but a dual maximization problem. Okay. So now let us say minimize W colon 0.12 x1 plus 0.15 x2. Subject to the constraints are x1 plus 60 x2 less than equal to 300. Second constraint is 12x1 plus 6x2 less than equal to 36. 10x1 plus 30x2 less than equal to 90. Less than equal to 90. So this is our problem where x1,
Sir,
x2
please
greater
put this
than
in the chat box, sir.
x2 greater than equal to 0. Hey, why are they coming in black color?
So we'll
Then
change the
the
color, sir.
data.
Thank you, sir.
Got it?
Yes, sir.
So in simplex method, what we will do is we will write the augmented matrix like this, right? 60, 60, 300, 12, 6, 36, 10, 10, 30, and 90, right? This is how we have done. And the last line we will write 0.12, 0.15, and we have the zero value here.
Sir, we call it augmented matrix.
Pardon?
We call this matrix augmented matrix.
This is called as augmented matrix. The first matrix which we create is the augmented matrix. I have just converted these values into a matrix form. Generally, we do it like this.
Sir,
Yes, please.
sir, can we write it in the maximization format, or
Yes.
do we have to write it like in this format only?
It is the what you call the minimization problem, which needs to be converted into a maximization problem, right? So I will select this matrix, Control C. So this is our actual minimization. This is our minimization, matrix, right? Now this matrix, Control C, I'll copy it and I'll select this cell, go to paste special and transpose. So when I transpose, this is called dual maximization augmented matrix. This will become dual maximization augmented matrix.
Sir, could you please show us once again how to do the transpose?
Copy and paste it as transpose. The straightforward transpose, right? Copy the whole thing and what you call convert it into transpose. The transpose function is there, right? Or wait, I will show you. You have to just select this data, Control C, select a cell, go to paste. You see transpose first or second row, third one in the paste special.
Got it, sir.
Now, this has become a dual maximization problem. It has become a dual maximization problem. So, dual maximize Z is equal to that is equal to 300y1 plus 36y2 plus 90y3 subject to constraint 60y1 plus 12y2 plus 10y3 less than equal to 0.12. Similarly, 60y1 plus 6y2 plus 30y3 less than equal to 0.15, and the values y1 comma y2 comma y3 greater than equal to 0. So now we have to solve for the maximization using this. Once we have solved the maximization, you will get the values as, here you will get x1, x2, here you will get y1, y3. So in the last row, you will get x1, x2. So simplex method will be applied on the dual maximization problem. We will have to rewrite the whole problem and implement the same simplex method.
Sir, I have a small doubt.
Yes, please.
Sir, so after this, we use the same method that we have done in last class, right?
Yeah, same method.
Sir, if we if we use the same method from start and then instead of maximizing the objective cell, we minimize, so that won't give the same answer.
That you can do in software.
Okay.
That you can do in software. But in what you call when you're manually calculating, you have to convert the minimization problem into a dual maximization problem. Then only simplex method will work. So simplex is majorly developed for maximization problem. It works well with maximization problem. So you have to convert the minimization problem into a dual maximization and then solve it. That is the procedure for solving minimization problems in linear regression.
All right, sir. Got it.
Got it?
Yes, sir.
All right. So, whereas in software we can directly do it, no problem. We can directly do it in software without any issues. So, let us say for our software calculation, x1, x2, w are minimized, right? So, 0.12, 0.15, right? Subject to constraints. What are the constraints? 60, 50, 0, not 0, sorry. We have to leave this cell empty, right? 60, 60, 300. The second one is 12, 6, 36. This one is 10, 30, and 90. Right. So this is one matrix. This is our other matrix. So minimize is equal to this into this plus this into this, and then is equal to this into this, except plus this into this. Then we'll drag it down. Right. Now we'll go to the data solver. Solver here, the objective cell is this. Then we have to change the max to min. Then we, by adjusting these values and add constraints. This less than equal to this, add this less than equal to this, add this less than equal to this. Click OK. And the method is Simplex LP. Solve. This solution. So we didn't get the answer yet. Why did we get the answer? Solver? Hey, you got the output?
No, sir.
No, sir.
No, sir.
Oh. I think we have to do the maximization table here. So we have to use the same maximization only. We can't do with minimization. So the this is we have to have
Sir, actually in minimization, the constraint should be greater than equal to.
okay. You got the output less than equal to?
Yes. Yes, sir.
1 second. Change the constraint.
So select and change.
Okay. Select change greater than equal to. Okay. Select change greater than equal to. Okay. After change greater than equal to. Okay. Oh, we got an answer, right?
Yes, sir.
The correct answer, let me check. Yeah, 3, 2. X1, X2 is 3 and 2. 0.66 is 33 by 50 is 0.66 only, right?
Yes, sir.
Yes, sir.
50 is 0.66. Yes, right. Yes, thank you, Yash. You corrected the mistake. Yes. It has to be greater than equal to. Perfect. Thank you.
So, sir, do we have to select the minimization or maximization in solver?
So I don't know. I think I've changed these values, right?
Sir, so in the question, it will be greater than equal to, I think. Initial that values that you have given, no? Subject to.
No, the minimization thing, what values it took? F16, F17. Okay, I think we have to give these values only, right?
Means,
No, the correct only, right. So these are the actual values, right? I didn't write the maximization problem. Just kept it as minimization problem only. 60, 300, 60, yeah. So we got 0.66 and 3 and 2. Minimize. The only change is we have to use greater than equal to less than instead of less than equal to, right?
Sir,
actually,
could you please show us the solver once again? Solver window.
Solver here.
Thank you.
So F14, and then these two are the constraints. Changing the cells in D13 and D14. Got it? Okay, shall we solve another problem? Then I think our doubts will be clarified.
Yes, sir.
Sir, can we do this? Like by dual maximization method, let us see if the answer is same or not.
Let us do a minimization and then we'll do that.
Okay.
Minimize W equals to 2x1 plus 10x2 plus 8x3. Subject to the constraints are x1 plus x2 plus x3 greater than equal to 6, then x2 plus 2x3 greater than equal to 8 minus x1 plus 2x2 plus 2x3 greater than equal to 4.
So it's becoming a formula actually.
Yeah.
You have to put it in bracket, I think, the negative sign.
x1 plus 2x2 plus 2x3 greater than equal to 4. And then x1 comma x2 comma x3 greater than equal to 0. So I'll paste this problem in the chat window.
So for the third constraint, it's the first x1 is minus x1, right?
Oh, minus. So will give x1, x2, x3, w, 2, 10, 8. This is minimize constraints 1, x2, x3 used allocated. So 1, 1, 1, 0, 1, 2, 8, minus 1, 2, 2, 4. Right. So we will type the formula. Is equal to this into this plus this into this plus this into this. This would be is equal to this into this plus this into this this into this. So solver minimize this comma by changing the values of these three comma add constraint shall replace this greater than equal to constraint this add shall replace this greater than equal to constraint replaces this add shall replaces this greater than equal to this. Click OK. Simplex and click. So, okay, we got an error here.
Sir, I got 36 as an answer.
You got
Yes,
what?
36.
36 is correct answer. So I made mistake somewhere.
Sir, you have to select minimum over there.
Oh.
in the
Minimization.
solve.
That's the problem. That is why it's given error. Yeah. 204 and 36. Yes. 204 and 36. So I forgot to select minimization.
Yes.
So here, do we have to select the less than or greater than?
Greater than, na? All greater than we have selected, right? The constraints are all greater than. See? Greater than equal to.
Sir, what it?
So I'm copying this problem in the chat window. You said you wanted some word problems, right? Yesterday.
Yes, sir.
So I pasted the problem in the chat window. You can copy paste the problem from there. All right, all of you get the problem. So what is the objective function? Refinery 1 and refinery 2. Refinery 1 and refinery 2 are there. So your objective functions will have C minimize cost. C equals to 20,000 x1 plus 25,000 x2. This is the objective function minimize. Subject to now we have to separate high grade. So there are three grades of oil. High grades are subject to. So we have three types of oil constraints. High grade is 400 and 300, right? So 400 x1 plus 300 x2 greater than equal to barrels. How many barrels we have? Totaling 25,000 barrels, 27,000 barrels, and 30,000 barrels. So 25,000 is high grade. Then medium grade, 300 x1 plus 400 medium grade in second, 400 x2 greater than equal to medium grade barrels are 27,000. Similarly, low grade, 200 x1 plus 500 x2. The third is 30,000 barrels. 30,000 barrels. So this is the minimization function obtained from the keeping x1, x2 greater than equal to 0. Now you have to minimize this function. So basically we have two costs, refinery 1 cost and refinery 2 cost, which will come in your objective functions, which we want to minimize. Then we have three types of oil: high grade, medium grade, and low grade. For high grade, maximum is 25,000 barrels. For medium grade, maximum is 27,000, and low grade 30,000. In refinery 1, high grade is 400. Refinery 2, high grade is 300. So you have to create constraints in that manner.
Sir, it has told us to minimize the cost, right?
Yes, minimize. That's what I wrote. Minimize C. C is cost.
So, sir, this subject to constraint should be less than equal to 20,000, na? The cost.
Pardon?
The subject to constraint, sir.
Ah.
It costs $25,000 per day to operate. The
Yeah.
first one.
Which 25,000? See, 25,000 is the barrels, yeah. 25,000 is the order of barrels of high grade oil. 25,000 is the barrels of high grade oil. 27,000 is the barrels of medium grade oil. 30,000 is the barrels of low grade oil they can produce.
So maximum production with minimum cost.
Yes. How many days should it run each refinery to minimize its cost and still refine enough oil to meet its orders?
Right, sir. Got it, sir.
Alright, anybody got answer?
Sir, 17 lakhs 50,000.
Okay. X1, X2?
2550.
5 and 50, sir.
Yeah. So X1, X2, 20,000, 25,000. Okay. So the constraints are 400, 300, 25,000, 300, 400, 27,000, 100, 500, 30,000. So it is equal to this into this plus this into this into this. This. Yes, 70,50,000, 25 days and 50 days.
Sir, how do we conclude this result, sir?
How do we
Conclude this result.
see if they run for 25 days refinery 1 and 50 days refinery 2, their minimum cost, they will have a minimum cost of $17,50,000. So the question is, how many days should each refinery run to minimize its cost and still refine enough oil orders to meet? So refinery 1 should run for 25 days, refinery 2 must run for 50 days, and the minimum cost then would be $17,50,000, and they will meet all the orders. They will meet all the requirement orders.
Okay, sir.
So
Sir, is it an optimized solution?
the optimized solution, yes.
And sir, what is the below one, sir? That is 400, 300, and after that 20,000 jo hai, that is.
What?
So in the subject, I mean, in the below part where you have this 400, 300.
Then the minimum number of barrels of high grade. So this is your what you call high grade, medium grade, and low grade with refinery 1. Refinery 2, high grade, medium grade, and low grade. So refinery 1 can produce maximum 400 high grade barrels, 300 medium grade, 200 barrel what you call low grade barrels. Refinery 2 can manufacture 300 high grade, 400 medium grade, 500 low grade barrels. So this is your high grade, this is your medium grade, and this is your low grade oil that each of them can produce. And these are the barrels. Maximum barrels of high grade can be produced. This is the barrels of low grade, medium grade that can be produced. This is the barrel. So these are the days. How many days it should run? So
And
this is demand.
so what is that in between, sir? That 28,000, 27,500, and
You
30,000.
can repeat that. See, this is your allocated demand. This is used for computation the maximum thing. This is the allocated values. Use. How many it is using? It is using 25,000 to 25,000, 27,000 is using 500 more, and 30,000 is keeping it more, and then it is minimizing the cost. So this is the actual delivery, actual production we have to do to get this cost for this many days.
Got it, sir.
So copied another problem. So what is the objective function here?
3x1 plus 2x2 plus 3x3.
So that we can take 3a plus 2b plus 3, right? No, not 3a. Shit. I'm also cut. What is the diet?
Sir, I guess
Sir,
8 vitamins plus 9 units of minerals plus 10 calories. That should be the output.
That should be the actual constraint, right? This is
Sir,
correct one.
objective function is the cost, na? So it will
Ah,
be 2 units of dollar and all.
subject to the one is what is that? First food A is what? Food A is one vitamin plus one mineral plus 2 calories greater than equal to sorry.
I guess, sir, we have to compile all the vitamins together and then we have to put.
One vitamin plus 2 vitamins, right?
Yes, sir. 1, 2, 1, 2, and 2.
2 greater than equal to 8. So next is minerals. 1m plus 1m plus 1m greater than equal to 9 plus 1c plus 2c greater than equal to 10, right? So A, B, C, then C, 2,
sir, in the constraints equation, there is one variable per equation. So won't we get the variable's value? Like directly solving them.
then
Sir, let's suppose the first equation 1v plus 2v plus 2v more than equal to 8. So we can just solve for v.
I didn't get you. Come
Sir,
again.
there must be three variables, three different variables per constraint, right, sir?
Yeah, here you can see here. We get all the high grades in one place, medium grades in one place, low grade in one place. So
Okay.
here we have three calories. Got it? See here, high grade with the constraint, medium grade with constraint, low grade with constraint. Same thing we are doing here. Vitamins with constraint, minerals
Okay.
with constraint, and calories with constraint.
Okay, sir.
So 1, 2, 3. So this is okay. This is 1, 1, 1. This is 9. This is 2. This is 10. So these are your vitamin constraints. This is your mineral constraint. This is your calorie constraint. So a diet should contain at least 8, 9, and 10. We have to look at the cost. Into this, into this, this plus this into this, plus this into this. So this is at least units. This is vitamin. This is at least mineral. This is at least cal. Got it? These are food A, food B, food C. These are foods. So now how much of ABC should be consumed meeting these constraints?
One eight zero.
Because cost is 180. How many of A and B and C?
How many?
Foods. A how many, B how many, C how many units of food?
1 unit of A, 8 unit of B, and 0 unit of C.
Okay.
So is it wrong?
No, I am checking. I also have to do, no?
Yes, sir.
This is equal to this greater than equal to this and this greater than equal to this. Okay. Simplex LP solve. Yes. So 19 is what I got, the first.
Sir, same, sir.
0 of A, 8 of 3, 8 units of B, and C, 1 unit of C. You also got the same thing?
Sir, I got 1 unit of A and 0 unit of C.
How come we got different answers? We should get same answer, right? Did you give greater than equal to, then minimize? I have given I-17. Okay.
So, okay, I have given somewhere wrong. Yeah. Sir, your answer is right, sir.
Yeah.
Sir, can you once show the solution of the previous one, sir? What was the exact answer? Sir, even I got a different value. I think I got the one Samijit had got earlier. I don't know the mistake I did. I just saw again. I got
So,
180.
the mistake that I did was instead of taking vitamin as 1 to 2, I took 1 to 3.
Okay, I've taken it 1 to 2, sir, but still I got 180. I don't know what mistake I did.
Check your solver observation in the number. That is the mistake you will do.
Okay, sir, I'll be checking again. So I'm getting ABC values different, but then the value, entire value is coming exactly the same. ABC values is coming different.
What you are getting ABC values?
180, sir. I'm getting in the reverse order. Food A 1 unit, food B 8 units, food C 0 units. I'm getting, sir.
Okay. 1 to 2, 1, 1, 1, right? Minerals is 1,
Yes,
1, 1.
yes,
And
sir.
1, 2 is calories.
Calories. Yes, sir. Okay, sir. I'll check it again. No problem. Thank you.
I10 10 equal to J10. 11 equal to J11. Okay, all of you are done? This is the correct answer, right? All of you got this?
Yes, sir.
Yes, sir.
This is a maximization problem. Try it. So I'll paste the problem in the chat window also. So what is the objective function here?
250 x1 plus 400 x2. Maximize profit.
Maximize P is equal to 250 x1 plus 400 x2. Constraints?
One is x1 plus x2 less than equal to 250.
x1 plus x2 less than equal to 250. Okay, what is the other constraint?
And
I think there is only one constraint here.
sir, $250 is the selling price, right?
Yeah.
So, sir, 250 minus 45 x1 plus 400 minus 50 x2 should be less than equal to 70,000.
No, cost is 250, 400.
Yeah, but that's a selling price. And they are saying that each model will have a $45 profit. So cost will be 250 minus 45.
No,
And
we are not.
total.
We are maximizing the profit only, right?
Yes,
So
sir.
the profit should be 45 x1 and 50 x2, right?
Yeah, profit.
Actually wrong. This is 45 x1 and 50 x2, right?
Right.
Right, and then this would be 250 x1 plus 400 x2 less than equal to 70,000, right?
Yes, sir.
This is the problem. This is the problem. So let us see x1, x2, p 45, 50. Subject to constraints 1, 250 is allocated, then 250 and 400, 70,000, right? So this is maximized. So into this into this plus this into this maximize profit. So we take the profit. So this would be equal to this to this plus this into this. So we'll fix this too and we'll drag the formula down. Now we'll go to data solver. This is the maximization only we are trying to do. Tool cell, add constraint, cell reference, this less than equal to this, add cell constraint this less than equal to this. So, okay. Yeah. So, he should stock 200 of X1, 50 of X2. He should stock 200 of X1, 50 of X2 to maximize the profit to 11,500. Got it?
Yes, sir.
So he has to stock 200 X1 and 50 X2 to maximum profit of 11,500 under the constraint of $70,000 inventory. All right? Got it, all of you?
Yes.
Yes, sir.